MS Ramaiah University of Applied Sciences.
Hello students, today we'll be studying about the interfacing of stepper motor with 8051 microcontroller. So as a first step, let us study what is meant by stepper motor, what all it consists of, and then how to control the stepper motor. So a stepper motor is a DC motor that moves in discrete steps. They have multiple coils that are organized in groups called phases. The stepper motor consists of 4 coils on the stator and a single or multiple pole pairs on the rotor. So, the controlling of the stepper motor. Figure shows the control of the stepper motor and how the coils are excited. There are 4 switches A, B, C and D connected to 4 coils respectively. When any one of the switch is turned on, the respective coil is excited. Now let us see how the rotor aligns itself when different coils are excited. When coil A is excited, the rotor is in position 1 or in 0 degree. When both coil A and B are excited, the rotor is in position 2 and aligns at 45 degree. When coil B alone is excited, the rotor aligns at 90 degree. When both coils B and C are excited, the rotor rotates and aligns to 135 degree. When coil C is excited, the rotor rotates and aligns to 180 degree. When both coil C and D are excited, the rotor rotates and aligns to 225 degree. When coil D is excited, the rotor rotates and aligns to 225 degree. When both coil D and A are excited, the rotor rotates and aligns to 315 degree. So, based on the sequence in which the coils are excited, there are different excitation methods, namely wave excitation, full step excitation, half excitation. Wave excitation. In wave excitation, a single coil is excited in sequence one after the other, such that the coil rotates 360 degree in steps of 90 degree each. The table shows the sequence of excitation. Full step excitation. In this excitation scheme, 2 coils are excited at a time in sequence such that the rotor rotates 360 degree in steps of 90 degree each. The table shows the sequence of excitation. Half step excitation. In this excitation schemes, a combination of wave excitation and full step excitation is used. In half excitation, a single coil and 2 coils are excited alternatively such that the coil rotates 360 degree in steps of 45 degree. The table shows the sequence of excitation. Now let us study how the interfacing of stepper motor is done using microcontroller 8051.
So now we will be starting with stepper motor interfacing experiment. One of the real-time applications using 8051 microcontroller is the stepper motor interfacing. In order to do the interfacing of stepper motor, the hardware components required are FRC cable, power supply cable, stepper motor kit. So this is the stepper motor kit. So this is the power supply connection, this is the stepper motor connection, and this is for the FRC cable connection. These are the 4 transistors and these are the 4 LEDs for the display purpose. RS-232 cable. So this is RS-232 cable which is used for serial communication. Whenever we are transferring the program from your computer in order to into the kit, we will be using RS-232 serial communication cable. 8051 microcontroller kit. So this is the 8051 microcontroller kit. The microcontroller kit consists of 8051 microcontroller IC, which is a 40-pin IC. All these pins are internally shorted and they are bought out here for external connection. And this is 8253 IC, which is for your timer interfacing. And these three are 8255 ICs, which are programmable peripheral interfacing ICs. These ICs are bought internally connected and bought out here for external connection. So this is the serial communication port which is to connect RS-232 pin here. And this is the power supply. So this is the USB connector in order to connect the keyboard, and this is the LCD display. So this is the reset button. Once you press this message will be displayed on your LCD screen. Keyboard. So this is the keyboard. These highlighted keys are the main keys in which we will be using for programming. Power supply. This is the power supply which will be connected to the board. Once we start with the experiment, we'll switch on this mains. And this blue colored pin is for the 5 volts power supply and the black one is for the common or the ground. Now let us download the hex file from the computer into the kit. For that we connect RS-232 serial communication cable. Now let us connect it from the keyboard. Double click on Talk software, select option, target board. In this, select 8051 kit and give OK. Now press reset and type E in the keyboard so that the display shows serial mode. Once you press E, this message should be displayed on the monitor. After downloading the hex file from the computer into your kit, now we should connect the stepper motor with 8051 microcontroller kit. For that, first let us connect this FRC cable from stepper motor kit to your microcontroller kit. So now we are going to connect a stepper motor with the 8051 kit. For that, this FRC cable should be connected to the stepper motor kit in such a way that this notch should be placed in the slot provided here so that it will be locked. Then the other end of the FRC cable is connected to the 8051 kit, such that this red wire should be connected to one of this pin, and the selection of this pin depends on the user manual which is given in the stepper motor experiment. So this is the power supply cable which should be connected to the stepper motor kit in such a way that this knot should be placed this way. So the other end should be connected in such a way that green and blue wire should be connected to the blue notch of power supply, which is 5 volts, and the remaining red and black wire should be joined and it should be connected to the common or ground point of the power supply. Now the stepper motor should be connected to the kit. This should be connected in such a way that this knot should be placed in this way. Now switch on the power supply, then press reset, then press go and provide the address location from which the program has started. 9000 is the address location from which the program has started. Give enter. So now the LED starts blinking so that each and every coil of the stepper motor is getting energized. And the stepper motor is started rotating. Hence the interfacing of this stepper motor with 8051 microcontroller experiment is completed.
At MSR UAS, we spark your imagination unlike any other.